Now see in this example, assuming the earth to be a sphere of uniform mass density, how much would a body weigh halfway down to the earth if it weighed 250 Newton on surface? So if you are going down and its weight is changing, it means you know it, weight is equal to m into g, that is on the surface of earth. If we go down, g is changing, as a result weight is changing. Suppose w dash is the weight below the surface. So we can write mg dash, and g dash can be written here m g into 1 minus d upon r, but you are getting d is equal to r by 2. It is given to the question in the question. So we can write mg into 1 minus r by 2 upon r, this cancel. So you will be getting mg into 1 minus 1 by 2, that is mg upon 2. This is w dash, and now mg, that is on the surface, already I have taken it, that is on the surface of earth. So mg given to us is, that is 250 Newton. So it will be here 250 divided by 2 is equal to 125 Newton. So if you are going down to the surface of earth by the depth of r by 2, then its weight becomes exactly half that on the surface of the earth. Now see, the next part is gravitational field. So what do you mean by gravitational field? Now see here, suppose you have got a body here of certain mass m, and now around this body there is a space where its force of attraction can be experienced by another body or by another mass. So that space is known as gravitational field of this body. So now we have to define here intensity of gravitational field. So see here, intensity of gravitational field, intensity of gravitational field. Now see here, suppose you have taken this body and its mass is m, and this is the center of the body. At a certain distance x here, this point, a mass is placed, that mass is suppose m naught, that is called test mass, and we can say also, we can take a unit mass. This test mass is taken in such a way that it does not affect the gravitational field of this body. So this mass is actually very small and it does not has much its own gravitational field. Now if this mass is placed here, the force is acting to this side, and this gravitational force is equal to gm into m naught divided by x square, and in vector form we can write here f dash is equal to gm into m naught divided by x square, that is minus x unit vector. So because x unit vector I have taken to this side. So intensity of gravitational field at this point is defined as, suppose this point is P, I is equal to F upon m naught. Now but here I have told you already, m naught is has very small magnitude and its gravitational field is also very small, it does not affect the gravitational field of this mass. So we can put all these values, we can get here gm m naught upon x square m naught, this is cancelled. So that is gm upon x square. So this is actually the force experienced by unit mass placed at this point. So thus the intensity of gravitational field at a point is defined as the gravitational force experienced by unit mass placed at that point. And here if you write in vector form, you will be getting here I, this vector is equal to minus gm upon x square x cap here. So this negative sign shows that here the gravitational force is attractive, and also this formula is the same as that of the acceleration due to gravity. So this is about the intensity of gravitational field.